Hi, this is Toby. In today's video, we will be finding the vertical asymptotes and the zeros of rational functions. The concepts we will be using in this video will be factoring, sketching a graph of a rational function, and graphing rational functions using a graphing calculator.
I have a question, Dave.
What's that?
When am I ever gonna use this stuff?
Well, that's a great question, Toby. And now you have put the question into the universe, and one day the answer will come. So here's our rational function. We have f of x, or y, equals x squared plus 7x plus 6 over x plus 3. Now, when we were simplifying rational expressions, you know what to do. We factored. So let's do this simple factoring and rewrite this problem as x plus 6 times x plus 1 over x plus 3. So this is great. So when we were simplifying expressions, we knew that x could not be -3 because we could set the denominator to 0. So I'm just going to come on over here and I'm going to write VA. VA stands for a vertical asymptote, and to get the vertical asymptote, we're going to set the factors in the denominator to 0. So we have x plus 3 equals 0, and of course x equals -3. This is the vertical asymptote of our rational function. We can find the zeros by setting the factors of the numerator to 0. Why, Mr. Fulmer? Because when we find the roots or the zeros, we are setting the value of y to 0. So if we set each factor in the numerator to 0, we have x plus 6 equals 0, and x plus 1 equals 0, and x equals -6, and x equals -1. All right, so we know that the vertical asymptote is at x equals -3. It's an equation of a vertical line. And we know the zeros are at x equals -6 and x equals -1. So I'm just going to come on over here and I'm just going to make a little sketch. This is not something that you need to worry too much about the sketch, because we're just going to sketch it and then we're going to use our graphing calculator to really finish it off. I'm going to put the major points. And we've got x equals -3. So we're just going to come on over here to x equals -3, and I'm going to do a dotted or a dashed vertical asymptote, VA. And that VA is x equals -3. And then I'm going to write the zeros, the places where the hyperbola crosses the x-axis at x equals 1, 2, 3, 4, 5, 6, -6, and x equals -1. So we have plotted the zeros and the vertical asymptote, and we know that this curve is going to approach the vertical asymptote, but never reach it or never touch it. But we really don't know just by looking at this from which direction and how the curve looks. So at this point, when you're sketching a graph, and what you can do with any function is start plugging in values. And for me, I would like to plug in the easiest values for figuring out what's going on with y when I plug in an x. And so I would like to know to see what direction is this curve going. I could plug in x equals 0. If x equals 0, I can figure out what y is and decide how is this curve looking, or how is the beginning of the sketch going to look. So I'm going to plug in x equals 0, and so that's just f of 0. And I could plug in 0 for all of these expressions in x, and that would make this very easy. X is 6, x is 0. That gets us 6 times 1 over 3, which is 6 over 3, which is 2. So f of 0 is 2. So when x is 0, y is 2. And now I can start to say, well, it's approaching this asymptote. And so now I'm just going to let that curve approach the asymptote. And I don't know where it's going. I could probably plug in x equals 1 and see what happens. And you'll get a y value a little bit higher than 2, I'm sure. And then we can start to say, well, if it's approaching negative infinity on the right side of the asymptote, maybe it's approaching positive infinity on the left side of the graph. And maybe we'll get something like this. It's just a sketch and an idea. The graphing calculator can help us do the rest. So here I am in the y equals screen, and I'm coming on up here, y equals, and I'm just going to punch this all in, and I'm not sure, so I'm going to be sure by adding parentheses. I'm going to take the entire numerator and divide it by the entire denominator. So just to do that, we've got x squared plus 7x plus 6. We have x squared. Oops, I forgot to put my first parentheses. So I'm going to come on over here, and I'm going to do second function, insert a parentheses, and then use my arrows to come on over here and continue. X squared plus 7x plus 6, ends parentheses, and I know that that means I'm dividing the entire numerator by not just x, but x plus 3. So I'm going to put parentheses down here, x. This is just a thing to remember. When you're punching in rational functions, it's always good to use those parentheses because now I've got that function. And all I have to do is graph. But before I do that, I like to I hate to press graph and then nothing shows up. And it's because I didn't check my window. So I'm going to come over here and check the window, and I'm going to make sure I have it under the settings already. My minimum x value is -10, so I'm going to go to -10 on the x-axis. And my maximum x value is 10, and I'm going to go by an x scale of 1. And at the same time, my minimum y value is -10, my maximum y value is 10, and my y scale is 1. So it's always good to set up your window. And when you're doing a simple rational function, this is a great place to start. So let's look. We're going to graph. And dun, 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 dun. Oh, there is one. Oh, it's fast. That is my hyperbola. Now, we don't see the vertical asymptote. But can we look at it? Let's look at this graph. We know the vertical asymptote is at x equals -3. 1, 2, 3. And if I drew a vertical line, it looks like I can draw a vertical line right on down through here, and it won't touch the first branch or the second branch of my vertical asymptote. Believe it or not, if you can think about this, those curves will approach the graph or approach the line x equals -3 and never cross it. It's getting loud in here and I gotta go. So here's the you try. I would like you to find the zeros and the vertical asymptotes of these three functions and sketch the graphs. They're pretty easy problems. Check them on the graphing calculator.
Thanks for helping, Toby. And thanks for asking that great question.
Anytime, Dave. And I'm still waiting for the answer.
I'm sure you are, my little mathematical genius. Thank you for being my video bomb, Blanquito.